All right, so we have the decision tree all completed. And our best strategy is to continue to develop the product in stage one, hoping we get FDA approval. If we get FDA approval, then we want to market the product, right? We want to market the product. And we're going to hope for a great economy, right? But we could get a fair economy, or we could get an awful economy, right? So we're not going to know the outcome of these until after this decision's made, right? So if we have these probabilities right here of each one of these three events happening, the expected net income is 1,074,000, right? And that's better than this option here, right? If we get FDA approval and we don't market the product, we're out the 4 million we spent here in decision in stage one, right? So it's pretty obvious that we want to do this instead of that, right? So you can kind of erase this, right? So if FDA is approved, we're not going to even consider don't market, right? We're going to choose market. And the reason why that is because if we don't market, we lose our 4 million in development costs in stage one. If we do market, the expected value of marketing is $1.074 million, right? Okay. Now, suppose we could maybe after we observe what the economy ended up being, great, fair, or awful, suppose we could observe all of these realities here, right? We have how many realities here? We got 1, 2, 3, 4, 5, 6. Suppose we could observe all 6 of them, right? In reality, we're only going to observe one of them, but suppose we could view all 6 of these outcomes, right? And then we look back and see what happened, right? So if we observe the world where we developed the product, the FDA approved it, we marketed the product, and the economy was good, then our net income would have been $4.8 million, right? I can click on this and show you that, right? So we spent the 4 million, we spent 2 million on marketing, and then our revenues from sales in a great economy were $10.8 million, right? Our gross margin was $10.8 million, right? Resulting in a net income of $4.8 million. Well, suppose instead we look at the situation where a fair economy happened, right? Well, when the fair economy happens, we lose $600,000, right? And the reason why that is because we had spent this 4 million to further develop the product. After we got FDA approval, we spent $2 million to market it, but because the economy was fair, our sales were not as good as they would have been had the economy been great. So we get 5.4 in sales in terms of dollars, resulting in a loss of $600,000, right? What about if the economy ended up being awful, right? What would we have observed? Well, we would have observed these outcomes right here, right? Where we had spent the 4 million on continue to develop. After we got FDA approval, we spent $2 million on marketing. Then we realized the economy is awful and our sales were only 1.6. And that results in a loss of $4.38 million, right? And then in this world here, this is the world where we decided in stage one to proceed and market. Although we didn't get FDA approval, although we did get FDA approval, we decided not to market it, right? Maybe we ran out of cash. I don't know. But for whatever reason, we decided not to market it, right? So we don't have any revenues at all to cover the cost of development, right? So that situation we lose $4 million. We just basically wasted that, right? In this world here, right? These two are the same monetary outcome, right? In this world here, we continued to develop product, but we got FDA rejected. The FDA rejected our product, right? Did not approve us, right? And so we don't spend marketing, we don't spend any money on marketing, and we collected no revenues. So we're out the 4 million, right? And then this final node here, this final branch, we just decided to abandon the product altogether, right? And so we incur no cost and generate no revenues, right? Now to calculate the probability of these things, right? I'm gonna make the probabilities bold. Probabilities bold here. We're gonna use the bold. Maybe I'll make them purple for probabilities, right? I'll make them purple for probabilities. Okay, so we got our probabilities in purple there, right? Now, FDA approval, I think one can make a really strong argument that FDA approval is not going to be dependent in any way on the future state of the economy, right? The FDA is not taking into account what the economy is going to do in the future. Like, they're not saying, I don't think the probabilities of drugs being approved has anything to do with the future state of the economy, right? Like, FDA officials aren't going, well, we believe the economy is going to be good in a year, so the probability of approval is going to be 0.9. Or the economy is going to be in recession in the future, right? So that's going to affect our decision on whether to approve or not approve a drug today, right? So those two things are independent. And because they are independent, since we need to calculate the probability of that, the 4.8 million, right, in net income, right? In order to get the 4.8 million, we had to have FDA approval, right? And the economy had to be great. And because they're independent, right? Because they're independent here, also the economy is not going to be dependent on FDA approval of a drug, right? I mean, a drug being approved is not going to really have any effect on the state of the macroeconomy, right? I mean, I suppose if there were no FDA drugs at all and a new drug was introduced and it received a approval from the FDA, well, I could see that leading to jobs and commerce, right? Which would increase GDP, right? But the FDA is probably considering thousands and thousands of drugs every year, right? Some of which it rejects and some of which it gives approval to, right? So the decision on any one drug is not going to have any effect on the overall economy, right? Now, if a small county had one pharmaceutical company and it was an independent little company, and this small county had 10,000 people in it, and that small county got an FDA approval, if the company in that county got an FDA approval, of course, it's going to have a huge impact on that county. But that's just one in thousands of counties in the United States, right? So the macroeconomic picture, FDA approval of a given drug is not going to have, if it has any effect, it's going to be really minuscule, right? So we're going to treat these two things as independent. So we can just multiply their probabilities, right? So the probability of FDA approval, and when we say and, we got to multiply, right? The probability of those two things is 0.360, right? I'll make that bold. Okay. What about, let me move it down here too. I'll move it right above this outcome. What about the probability of losing $600,000, right? Well, we got to multiply the probability of fair times the probability of FDA approval, right? So right here, we're going to type, for this outcome to happen, we have to have FDA approval and, so multiply, the probability of a fair economy, right? And we get a probability of 0.280, right? Okay. Suppose this outcome occurs, right? And that outcome is a result of spending $4 million on developing, continuing to develop, getting the FDA approval, and spending an additional $2 million on marketing. The economy ended up being awful, so we only made $1.62 million on sales, right? So the probability of this event is the probability of awful and the probability of FDA approval, right? So we're going to multiply 0.2, the probability of awful, by the probability of FDA approval, because when you multiply those two probabilities, that is the event FDA approves and the economy was awful, right? And that's 0.160, right? Now, we're not going to calculate our probability for this outcome here. And the reason why that is because if you get FDA approval, right, suppose you got FDA approval, you're going to decide between marketing the product or not marketing the product. And according to this subtree here, you don't want to consider don't market it. You want to go all in on marketing it, right? So we're not going to calculate the probability of this, right? We're going to skip down to this one down here, right? So this outcome down here is a minus $4 million. That comes from the fact that the FDA rejected the project and we abandoned it, right? If the FDA rejects our application for approval, right? If they reject it, well, there's no way in heck anybody would continue to develop and market it, right? There's no way you do that in the United States. You'd abandon this in the United States, right? That doesn't mean you don't, try to do that in another country, but for your operation in the United States, FDA rejection means you just scrap the project, right? And the probability of that happening is just 0.2. Now we know that we've created a probability distribution because if I add these four probabilities up, right? If I add those four probabilities up, I get down here, I get a sum of 1. You see that? So I've created a probability distribution. And so the chart data here, the chart data that goes here, that chart data is just the values, the monetary values, right? These monetary values and their probabilities. So let's go back to the problem here. Let's fill in the information. Okay, so if the company, I'll put it right here. If the company develops the new drug and gets FDA approval for it, its net income would be what? Well, the 4,800,000, right? In a great economy, right? In a fair economy, it would be a negative 600,000, right? And then if we proceed to market, we get FDA approval, we market the product, and the economy's awful, then our net income is negative 4.38 million, right? Negative $4.38 million, right? Let me hit, and well, let's go ahead and finish this. Okay. And that's an awful economy. Its expected net income of launching the new drug, expected gross margin, less the fixed cost equals what? So this right here is, this amount here is the expected net income, right? Expected net income. And each one of these includes these costs here, right? This value here is 59,200, right? Because we don't know if we're going to get FDA approval or not. We got to knock this 1,074,000 down a little bit because we don't know if we're going to get it, right? If FDA approval was certain, then this value would be 1,074,000, right? But FDA approval is not certain. So we have to weigh these two values by these two probabilities, right? Okay. So it's expected net income of launching the new drug, expected gross margin less the two fixed costs equals 59,200. Oh, wait a minute. Okay, so what goes in this box here? Sorry. What goes in this box here is the net income of launching the new drug, right? The expected gross profit less the two fixed costs. Each one of these three net incomes was calculated by subtracting off the 4 million and the 2 million, right? So at this node here, right? At this node here, we prefer this to losing 4 million, right? So we don't want to choose don't market the product because we'll lose that $4 million. If we market, we have the opportunity to earn enough revenue, enough expected revenue to at least pay this off, right? And more than that, right? So the value here is the 1,074,000, right? And the probability of this happening, right? The probability of this happening is 0.8. Or this 1,074,000, you could add these three probabilities. If you add these three probabilities right here, you'll get the 0.8, right? So this probability, the probability of this event is 0.80, right? Now, if this number here, this 1,074,000, if this probability were like, say, 10%, and this was like 10%, and this is 80%, then this number can be negative. It can be maybe a lot more negative than this, right? So as these two probabilities go to 0 and this probability goes up, this goes increasingly negative. So it could be the case that maybe, if these probabilities shift because all of a sudden analysts are saying, oh, the economy looks like it's going into recession, or the likelihood of recessions start to increase, right? Then maybe these three probabilities are adjusted downward. These two are adjusted downward, and this one's adjusted way up, which results in this being, say, minus 5.5 million. Then you'd go to don't market, right? You basically just shelve it until maybe in a year when the economy's coming out of a recession, right? And then these three probabilities, these two improve dramatically, and this drops off, right? So that's why you might choose don't market. Because these probabilities are based on what people are feeling at the moment, right? Some economists say we're headed for a recession. Some are saying we're headed for a soft landing. And some are saying we're not going to have a soft landing. We're going to continue to grow, right? So there's a lot of disagreement on what these probabilities might be, right? One set of economists may say, hey, these are probably likely. These three outcomes are probably likely. These probabilities are probably likely. Another economist might say this is 10%, this is 10%, and this is 80%, right? So it depends on who you're listening to as well, right? Okay, so if the economy develops the new drug but does not get FDA approval for its net income, doesn't get approval for it, its net income would be what, right? If it doesn't get FDA approval, so if it ends up down here, its net income would be minus 4 million. it'd be minus 4 million, right? So, and that doesn't matter. It doesn't matter what the economy does, right? Because the economy, when the economy goes into recession, or it's great, or it's fair, or it's awful, that's not going to affect this, right? Because we never got to that stage, right? We've lost the 4 million. So this is true for an awful economy, a great economy, and a fair economy, right? These are all 4 million. A loss of 4 million, right? All those are loss of 4 million. Okay. And then the net income of this outcome is, minus 4 million. I mean, if you really want to think about it, you can multiply this 4 million, negative 4 million times 0.45. You can multiply this minus 4 million times 0.35. You can multiply this minus 4 million times 0.20. And when you add that up, you get minus 4 million, right? And the probability of that occurring is what? Well, the FDA rejected your application, correct? Let's see if we got these right. Okay, it looks like we got them all right, right? Now, whereas the expected net income of launching the new drug equals, okay, so we got $59,200, right? It's $59,200 because we're gonna continue to launch the product, right? And then the if we don't do that, then the expected net income of abandoning it would be to zero, right? So at this point, stage one, we're proceeding to market or we're abandoning it. And if we proceed, it's 59,200. If we abandon, it's zero, right? Now this is where the so since the former is greater than the latter, since the former 59,200 is less than the latter, zero, right? The company should develop and market its new drug, right? Sorry, I clicked the wrong one. Since the former 59,200 is greater than the latter, so I just picked the wrong one. I chose the wrong one. I went ahead and fixed that. Then we should go ahead and develop and then market it, right? This new drug, right? And the EMV is the weighted average of all possible monetary outcomes of a given strategy, right? Now, there are three strategies in this model. Continue to develop, that's the first stage decision, and market the FDA-approved drug, second stage, right? Or we could continue to develop the first stage and then don't market the FDA-approved product, second stage, right? Okay, so I had to fix the this should have been, it was stage, and I think I fixed the stage. Sorry about that. So A strategy, continue to develop first stage and market the FDA approved product in the second stage. B, we continue to develop in the first stage and don't market the FDA approved product in the second stage, right? And that would be a situation where maybe the probability of, let me get in here somehow. Maybe the probabilities change for, maybe use a different economist, probabilities. Maybe the probability of great drops to 0.20 and the probability of fair drops to 0.20. And maybe the probability of awful increases to 0.6, right? Okay, so if use a different economist's probability for great, fair, and awful, then if you market, right? If you market, if you market it, the better decision, instead of marketing the product that's been approved by the FDA, is you don't market it, right? Oh, you would still market in this situation because you're not losing as much money, right? So you're still going to market it, right? But suppose the probabilities change to, I don't know, the situation gets even worse, right? Maybe the probability of the economy being great drops to 10%. The probability of it being fair drops to 10%. And the probability of awful drops to 0.80%. Okay. You still want to market the product because now you're only losing $3 million rather than losing $4 million, right? So you're still going to proceed to market. You're still going to proceed and then market an FDA-approved drug, right? Over, don't market. So how low do the probabilities have to get? Let's try 0.05, 0.05, and then 90%. Even this situation, we're down to 0.05, 0.05, and 0.9. Marketing an FDA-approved drug is still preferred to don't market, right? So let's see how far we have to go on the probability. Let's try 0.02, 0.02, and 0.96. Now look at this. If the probability of great and fair drop to 0.02, and the awful probability is 0.96 because things have really gotten bad, right? Some guy's been elected office, he or she signs a bunch of executive orders that really restrain the economy and causes 30% unemployment, right? What should you do now? Well, if you got FDA approval, the best decision now is to not market the product, right? Because not marketing, you're only losing $4 million. If you market it, you're going to lose more than, you expect to lose more than $4 million, right? So if you don't market, you only lose the $4 million that you okayed in stage one of the decisions, right? So in this situation, when the economy deteriorates so poorly, and the probability of awful is almost 1, the best thing to do is not market it. And maybe what you do is, instead of marketing it, right? Maybe what you do is you just kind of like ride the bad policy out until the next election, and maybe a new president comes in and reverses all that the current president is doing, right? So that's something to think about, right? So let me restore these probabilities here to what they were originally. There we go. All right. And then C is abandon the product in the first stage, right? So that's the other one you can do. You can abandon the product in the first stage. The expected monetary value of a decision tree is expected value of the probability distribution of the outcomes, which in this exercise are the net incomes of outcomes of the best strategy. If the decision tree indicated strategy B was best, right? Suppose strategy B is best because these probabilities drop to 2% and this is at 96%, right? Then this would be more negative than that, right? So don't market an FDA-approved drug, and abandon the project are the two best outcomes, right? And in that situation, you're going to lose 4 million, right? So if we go back to that situation where this is 0.02, the probability of great economy is 0.02, the probability of fair economy is 0.02, and the probability of awful is 0.96. Then you're not going to, then this right here, the optimal decision comes down to this right here, right? Comes down here to don't market. Right? This is your optimal path. This is your optimal decision now, right? Don't market an FDA approved drug, right? And so your two outcomes become these two, right? This has a probability of what? This has probability of 0.8, right? We're not going to consider this stuff up here, right? So that we're only going to consider these two things. So we got 0.8 times a negative 4 million plus 0.2 times a negative 4 million, right? Which makes sense because we're going to end up spending $4 million, right? But that's not the case here, right? The case is we're using economist estimates of the probabilities of the economy being in three different states of being 0.45, 0.35, and 0.2, right? So. Right. Since strategy A was determined to be the best strategy, the E and B of that decision tree is what? Well, that's the 59,200, right? The outcome of the strategies are FDA did not approve it. FDA approved it. FDA approved it and will market it in an awful economy. FDA approved it and will market it in a fair economy. And FDA approved it and will market it in a great economy. So I use the word ands, right? So when you build this chart data, right? This chart data, this is the risk profile. And what you want to do is you want to start at the dollar values, right? Associated with each one of these with each one of these probabilities. You want to put in the dollar values from lowest to highest, right? So over here, our lowest value of the four possible outcomes, right? When our best strategy is to proceed to market and then market it if we get FDA approval, right? We have these four outcomes here, right? We have this one, we have this one, we have this one, and we have that one. This is the highest, this is the lowest, this is the second lowest, and this is the third lowest, right? So when you're filling out your risk profile, right, I want to put in the lowest monetary value. And the lowest monetary value is minus $4,380,000 in a loss, right? So $4,380,000 in a loss. And the probability of that occurring is 0.16. That probability is 0.16 because in order to lose $4.38 million, we had to multiply the awful probability times the FDA approval probability, right? Because under this losing 4.38 million, we're saying the event is the FDA approves and the economy is awful, right? And we have to multiply those probabilities. The next lowest value in our risk profile is the the 4 million, lost 4 million. And that probability is 0.2, right? And then the next lowest net income value is minus 600,000. And that probability is 0.28. Okay. And again, the way we got that probability of 0.28 is we use the joint probability rule, right? Multiplication rule for probabilities. Fair economy, the economy being fair and FDA approval are independent events. So you can just multiply 0.8 times 0.35 and you get 0.28, right? And then the highest monetary value that goes into this calculation 5,000 or 59,200. The largest value is 4.8 million. Okay, and its probability again is found by recognizing that the state of the economy and FDA approval are independent. So all we have to do is multiply the probability of approval, 0.8, times the probability of grace, because we're talking about the event FDA approves and the economy is great. So multiplying 0.8 times 0.45 is 0.36. Okay. Now, according to the table above, the probability of strategy A results in a loss, right? According to the table above, the probability of strategy A continue to develop and market the FDA approved product is found by recognizing that the first three values are all three negative. So the probability of strategy A resulting in a loss, right? The probability of strategy, this is strategy A here, right? The probability of strategy A resulting in a loss is what? The probability that net income is a negative 4.38 million, or the net income is a negative 4 million, or the net income is a loss of 600,000. And I'm using the ors, right? I'm using the word or, which means I have to add these three up, right? These three probabilities up. So I got the probability of event number one, or the probability of event number two, or the probability of event number three, right? That's why you generally write these in ascending order, right? Because it makes it easy to calculate union probabilities, right? Because union probabilities, again, use the operative word or. One or two or three happens. When I have or, I can just add these probabilities, right? So when I do that, I get 0.64, right? I can come over here and I can do 0.2, 0.16, and 0.28, and then go to the bottom of Excel, and their sum is 0.64, right? So I'm tired, but I'm not as tired. I'm not tired enough not to be able to do arithmetic in my head. Okay, where am I at? So the probability of strategy A resulting in a loss is 0.64, right? The probability of the strategy making the company more money, is 0.36. There's only one outcome down here that is positive, right? So we're talking about the probability of number 4 happening, right? Which is 0.36. So although the expected monetary value is 59,200, you got to remember what that is. That right there, it is an expected average of all possible monetary outcomes, right? So the tree is saying, right, if what the tree is saying is we want to continue to develop the product, and then if the FDA gives us approval and will put its approval on our drug, then we want to market it, right? And that right there will on average generate $59,200 in sales, expected net income, right? But if you're looking at just losses and positive gains to this decision, the probability of a loss, right, is a lot more, is much larger. Making a loss is more likely, making any loss is much more likely than making a profit. So you got to kind of keep both in mind there. Okay.